Hello everyone, welcome to the fourth week of IOQM preparation. We are finally entering geometry. Hello everyone, welcome to the second video of geometry. We will cover the basics today. It is going to be a very chill session. We'll start to see how geometry would have developed and how Euclid would start doing stuff. Right, construction of triangles is one of the important things, and we will end our today's lecture there. That's the plan. So let's see. So the title says points, lines and shapes. So where does geometry actually begin? The geometry begins with a point. The most basic geometrical structure is a point, right? And this has a point has no dimensions. No dimensions. To give it a dimension meaning some kind of measurable thing. So point is not measurable technically speaking, right? For it to be measurable, we need another point, and when we join two points, we call it a line segment. Okay, that is a line segment because it is part of a line. We cannot say it is a line because a line by definition cannot be confined within 2 points. So this which can extend on both sides is called a line. And if there is only one end point and the other is going, of course this is called a ray. Yeah, sun rays have one origin point and it is extending towards the other side. So that's the idea of lines. Now, so the moment we have 2 points, we have a line segment. Now this is one dimensional. All these things are one dimensional. Okay, right? Because they have only one direction in which we can measure them. Number of directions. What is the dimension? Dimension is the direction where we can do some measurement, right? So lines or line segments or rays, all these are one dimensional thing. Point is a 0 dimensional thing. So what is a 2 dimensional thing? Well, if we have 2 lines, now we are entering the realm of 2 dimensions, because now there is a possibility that we have to measure stuff in 2 directions, right? So the concept of an angle, when 2 lines have a point common, we have an angle, right? So when 2 lines have one point in common, then we have an angle. This is called angle. So you see, angle is not a number. Although we try to measure it in degrees is not really a number, like you cannot like physically measure it. It is a man-made thing, just like centimeters are a man-made thing. Centimeters or inch, how do you like know which is original? We don't, right? So angles are not measurements. Angle is not a number. Angle is the natural formation which we see due to the intersection of 2 lines. It exists all around us, right? Whenever we have anything, so here is the right angle. You see that the screen is in a rectangle, so it has 4 right angle, and you know my eyebrows, if extended, they will meet at a certain angle. You know, my fingers, they are between any 2 fingers there is an angle. So if you want to see that, it's everywhere. So we will look at how to think about the angles. So for convenience, the whole is measured with 360 degrees, right? Or it implies when I have a line, each side is 180 degrees. That's what we will use. Why do we have this particular number? It's not a naturally occurring number, just that it can have a lot of divisors. This number is convenient to use, but later on we will see why radians are more natural. Yeah, angles are measured, you know, radians are more natural, or rather are natural, right? Radians are natural. Now if that is so, that means if I have any 2 lines intersecting, it will have 1, 2, 3, 4 angles. So it is notable that angle 1 plus angle 2 is 180 degrees, right? Because one side of the angle is always 180 degrees. And if you consider this line, let's say this is line L1, this is L2, this is from L1. Now from L2 we see that angle 2 plus angle 3 is 180 degrees, right? This is from L2. So that implies that angle 1 must be equal to angle 3, right? Because these 2 are equal and 2 we can cancel that out. So that gives us angle 1 is equal to angle 3. This is called, what is this called? Vertically opposite angles, right? Vertically opposite angles are equal. Okay, that was easy to see. That is the first observation. And similarly we will have angle 2 is equal to angle 4, right? Okay, so we got to that point, and then what else can we do? So that is 2 dimensions. Now suppose, now this is what we get from intersecting lines. Intersecting lines. We are only talking about intersecting lines here. Now let's say if two lines are non-intersecting. These 2 lines are non-intersecting. L1, L2. So how do we even talk about that? To talk about it, we need to have a relative line, because if they are not intersecting, there is nothing to measure. So there is nothing to measure directly for L1 with respect to L2. So we draw another line, a dummy line, let's say. This is called T for transversal. Now what does this transversal do? It creates 4 and 4 angles here. So suppose in the first one I had 1, 2, 3, 4, 1, 2, 3, 4. Oh, or we, as of now we don't know whether it is 1, 2, 3, 4 all over again. So let me use 5, 6, 7, 8. These are the angles, right? Now we know that angle 1 equals angle 3. Why? No, vertically opposite. Vertically opposite. And so is angle 5 equal to angle 7. Vertically opposite. there is something called corresponding angles, and this cannot be proved. We don't have any other way to prove it. So in some sense, line 1 is equivalent to line 2 with respect to the transversal T. If I call this line to be T, right? With respect to T, line 1 and line 2 are exactly equal. They will have exactly the same properties. So what we will do is we equate these two. Angle 1 is equal to angle 5, and we call them corresponding angles. This corresponding angle is the starting point of, this is the only basis for studying parallel lines. This is the only basis, corresponding angles is the only basis to study parallel lines. There is no other way. You cannot compare these two lines in any other way. Only the corresponding angles will give us the path towards something different. So suddenly we have angle 1 is equal to angle 5, and already we had angle 1 is equal to angle 3 and angle 5 is equal to angle 7. So we have these four angles to be equal. These four angles belong to one category. All these four angles are same, and similarly we will have angle 2 is equal to angle 4 is equal to angle 6 is equal to angle 8. Okay, so now if you see the pair 3 and 5, angle 3 equal to angle 5, this is called alternating interior angles. Right? Right? Alternate interior angles. So what are the angle names? Let's look at them again. Corresponding angles, vertically opposite angles, alternate interior angles. So let me point them out once again. Suppose I have two parallel lines. I have this 1, 2, 3, 4. Right? So if I am considering only these four, angle 1 is equal to, so I'll write them down. Corresponding angles is angle 1 is equal to angle 3 and angle 2 is equal to angle 4. Vertically opposite angles is angle 1 is equal to angle 2 and angle 3 is equal to angle 4. If someone is totally new to geometry, this is kind of important, right? This is important. Alternate interior angles, angle 2 is equal to angle 3. This is it, right? Probably 1 and 4 are called alternate exterior angles. Alternate exterior angles. Angle 1 is equal to angle 4, right? So that is the basis of the beginning of geometry. I hope this is clear to everyone. Okay. Now this is important because generally there is a concept in geometry called angle chasing. Especially it is a big technique, very useful technique used to find a lot of things. Recently Sumit Sir of Viewers original channel, he proved an RMO question. He gave the RMO solution under 1 minute in a shot. I am pretty sure you'd have watched it. So that's a very fascinating thing, that angle chasing helps us a lot, and especially when we learn circles. In circles, the relation between angles and everything, it is an amazing thing. Geometry is going to be a wonderful journey for me and for you. I wish to do a lot for this. Now let's look at these Euclid's axioms, which I hope you watched in the previous video. Now it says a line segment can be drawn using any 2 points. So we have 2 points joined, it is called a line segment. Any straight line segment can be extended to indefinite line. So if I have a line segment, I can extend it to make it a straight line. So he is kind of hinting on the, so we generally do it in a triangle, and we extend this to a point and we intersect this. We are able to do this because of the postulate 2. In triangle ABC, let us extend CV to a point P such that AP is something something something. If we are doing something like that, we are able to do because of postulate 2. It might seem very non-important, but it is actually quite important. This is also a very basic thing, but we have to assume it, that something joining 2 points is a line segment. Yeah. Given any straight line segment, a circle can be drawn having the line segment as radius and one end point as a circle, as the center of the circle. So you see, earlier all the constructions we used only a compass. I hope you know what a compass is, right? So it's a device like this. Here you hold your pen or pencil, right? You hold your pen or pencil, and then the device, it's like there is a pointy thing here. Here you put the center and you rotate, right? So let me try to draw it. Okay, we already have here something. So suppose I have one line segment, we have a line segment. So if I am holding it like this, I can draw a circle, this as the radius and 1 point as the center. That's it. That's what it says. Nothing much, right? So all the constructions, we will talk about triangle constructions as well. When we talk about congruency of triangles, it is important to understand why we have only them as the congruency, rules, conditions. All right angles are congruent. So wherever you see a right angle, this right angle and this right angle, or this right angle, or I don't know, this right angle, all right angles are the same. That's what he's saying. That's obvious, but also we have to assume it when we are saying 2 angles are same. He is basically saying any 2 angles are same, because at the end we are dividing the right angle only in different ways. If 2 lines are drawn which intersect a third in such a way that the sum of the, so basically he is talking about non-parallel lines, right? So when we have 2 lines such that if I have this thing and I have this angle alpha, this angle beta, and he says that if alpha plus beta is less than 180 degrees, if, right, then that implies upon extension they will meet. They will meet. You understand? That's the 5th postulate. That's the 5th postulate. So also I should have mentioned here, right, that you should see this also. Angle 3 plus angle 6 is equal to 180 degrees, and so is angle 4 plus angle 5, and so are many other angles. I mean, you can check that, it's not a big deal, easy to see, right? Once these are equal, just seeing that, you know, these 2 are supplementary. Also these kind of angles are called, they are called supplementary angles. Supplementary. It is not supplementary. No. Supplementary. And it is not complement wala complementary. No. Complementary, which adds up to 90 degrees. Right? Okay. So we'll talk about them. Don't worry. If two lines are drawn, so this is what we talked about. This is the fifth postulate, right? I hope this is clear. So this also we saw, right? This is called parallel postulates. Now let's talk about triangles a little bit, very briefly, not much. We will not cover a lot in this video. Tomorrow I'll do extensively, or in the next video I'll do extensively about triangles, right? Construction of triangles and everything. So we'll see that when we take three lines. So far we dealt with two lines. Now we deal with three lines. So what happens when we have three lines? We form something called a triangle because we have three angles. 1, 2, 3. A natural question is, what can we say about these? Because this need not be equal. We see that when I take a different shape, I can make different type of, there can be numerous. So I can take different shapes with three lines, right? So these kind of things are possible. So what can I say? So one thing one would note is trying to find the sum of angle 1 plus angle 2 plus angle 3, right? Naturally that curiosity must occur. Another thing one must note is the relation between this, there is intersection points. We have intersection points. What is the relation between this? So for the sake of convenience, we will call this A, B, C. So what is the relation between? Relation between A, B, B, C and C. And why do we even have that, right? Then we'll see what happens if we have two triangles. How do we even construct a triangle? How much information do we need to be able to construct a unique triangle? Unique, right? So all that we will see. So let's look at the angles first. So I have a triangle first of all, right? So I'll call this A, I'll call this B, I'll call this C, and now a following construction will be made. We draw a line L such that L is parallel to BC, right? L is parallel to BC. Then do you see that AB and AC act as transversals? AB and AC act as transversals. That means, look at this angle X, look at this angle Y. This angle is anyways A. Now one thing I can say that angle A plus angle X plus angle Y is equal to 180 degrees. This I can say because one side of the line, one side of line L, right? So look at transversal AB, implies this angle X and angle B, angle X and angle B are alternate interior angles, and so are angle Y. If we take transversal AC, angle Y and angle C are also alternate interior angles. So if we have that, that implies angle X is equal to angle B and angle Y is equal to angle C. So that should imply that angle A plus angle B plus angle C is equal to 180 degrees from this. So that's how we prove sum of the interior angles of a triangle. So this is called sum of interior angles. Right? Is 180 degrees always. I hope that it is clear. Interesting? I find this very, very interesting and very easy, not much hard or anything. Now let's talk about if I have a triangle again. If I have a triangle again, what is the condition on the sides? What can we talk about? What can we talk about? AB, BC and CA. Right? This is a very valid question. What is the condition of formation of a triangle? Now, tell me one thing. Let's look at, say we have 3 sticks. Say we have, you are given sticks to form a triangle. So let's say you are given a stick with 1 meter long, 2 meter long and 3 meter long. Can you make a triangle? Is it possible to make a triangle? It won't be possible, because can triangle be made? So if you take the 3 meter long stick here, this is the 3 meter long, and then I have a stick with 1 meter here, and I have another stick with 2 meters here. So clearly 1 plus 2 is equal to 3. So if I put the 2 sticks together side by side, they form the third stick. So no triangle will be formed. This is the 3 meter, the 1 meter and 2 meter will be here only. There won't be any triangle formed. So no triangle is formed. Okay, isn't that interesting? Now, so when will a triangle be formed? If I have, suppose if I have 2, 2, 3 long sticks, can then be formed? Let's see. So if I have a 3 meter here, I form a 2 meter here, form a 2 meter here. Is this possible? Because 2 plus 2 is more than 3. If I join this, there will be some height. This won't be 0. Not equal to 0. This will be. Right? So the condition, if you see, that if in AB, BC and CA, okay, I don't know what's happening. CA, let's say CA is the longest. CA is the longest. So what does that tell me? That implies AB plus BC together must be greater than CA. Only then a triangle can be formed. Right? So this is called, this inequality is called, this is called triangle inequality. Alright, this is called triangle inequality. So this should be true for all three sides. So if A, B and C are side lengths of triangle ABC, then A plus B must be C, B plus C must be A greater than A, C plus A must be greater than B. Must be true. Otherwise, no triangle formed. Otherwise, ABC is not a triangle. Right? So today we did something very basic. That's all for today. So we covered everything from one dimensional. So we started from one dimension, zero dimensional. This is zero dimensional. And then we did one dimensional. Then we are doing two dimensional. These are all two dimensional things. Right? This is two dimensional. We will completely cover two dimensional only. In Olympiads, we only require two dimensional geometry, Euclidean geometry. Non-Euclidean geometry are especially seen in only 3D geometry, just that because we are talking about curved surfaces, so it has to be in 3D. So Euclidean geometry, the beginning has begun, and I hope we'll have a wonderful journey from here on. Right, hope you enjoyed this. Stay tuned. Tomorrow you'll get another one. That's it. Take care. Bye bye.